Caltrans and code for Sacramento. So here to talk about one of our topics very near and dear to our hearts at Caltrans, trash. So this is a kind of abbreviated version of the talk that we gave about 2 weeks ago over at the State Water Board water data event. They do a big symposium for data scientists. A lot of interested data science around water quality and water rights and things of that nature. So we fit in with that because we are a major operator within the state. We have the state highway system, and so as you all have noticed, when you drive the highways, there is plenty of trash out there. There's no shortage, there's encampments, there's dumping. What we're interested in is litter, so that would be of a particular size. We're concerned about mattresses and things like larger, in size. So that's what we're talking about when we talk about trash, is litter. So talk was with myself and Gary Conley from Second Nature, which is a consultancy that we paired up with to develop this project. So like I said, to frame the problem, right now there is floating in the Pacific Ocean about 88,000 tons of trash. It's called the Great Pacific Trash Patch. Look it up, it's a thing. It's about the size of Texas. I had to look it up today to see it and believe it. So it's a very tangible problem because in the state right away and basically all service like local streets, when it says drain to the bay, it drains to the bay. So trash that is being discharged on the highway that is not caught basically discharges into sewage plants and wherever else. And a lot of them end up in outfalls and they end up in the ocean. So that's why we're interested in it as a pollutant. And of course there's regulation. The other that was the carrot, this is the stick. So the California Water Board is now enforcing, effective basically immediately, the California Trash Amendments, which is in enforcement right now for all cities, counties, including us. So basically, everybody is going to meet. So the goal is protect aquatic wildlife, but also pollutants. And so these pollutants, when they get in, they like to bind to trash, which are small objects like cigarette butts, pieces of paper. They bind to it, which includes metals. So for the state right away, when it rains off the highway, there's a lot of pollutants, and then these bind to the little pieces of trash that then get discharged into the ocean and other places, harming aquatic wildlife, and in some cases, depending on where it ends up, it could impair water bodies, lakes, things of that nature. So we're very concerned with that. Full compliance within 10 years, so everybody's got to get cleaned up through 2 methods: full trash capture, which are actual devices, which would go into storm drains like that. So we would put a basket, so we're pursuing that. The other option, and we're doing that because there's certain rules around where and when you can put them in, is to do actual structural control. So this would be the actual trash cleanup, and that's where image recognition comes in, because when you do just regular cleanup through, say, street sweeping or people picking up trash, you have to go through visual assessment. So these are the 4 grades that everybody that's under this trash amendment is going to basically go by these 5 standards: low, moderate, medium, moderate, high, and very high. So sadly, most of our stuff is like this. We want to get there, but not there yet. So this is where the data comes in, because a part of understanding and doing these assessments, right? If we're not going to do inlet inserts or devices, we have to go do cleanup. So Second Nature did a study, or one of their clients, the city of Salinas, and so what they did is they basically track all the data of going out and doing assessments. So, on the left there's the map of doing assessments, and then here on the right is basically the level of certainty. And so when you put together like the low, medium, high rated areas, what they found was that the areas that are high and very high, basically low and medium stayed low and medium. This meant like, it's in a rural area or in an area that's not heavily traveled. However, once it got the high and very high, the patterns, the autocorrelation, the spatial, the temporal aspect of it, it tended to fluctuate a lot. So it's hard basically to say that these red areas, which is the higher area, or those were the low areas, but these that were very high in the center, probably the urban areas, they tended to move around. And that's also something we found within Caltrans, is when we go out and we drive a highway, one stretch would be high, we do some cleanup, and then it moves, right? Because naturally, if you think about it, trash is coming off of trucks, people are littering, wherever it's coming from. It's coming from different sources at different times, and so it's kind of a moving target. We can go clean up, and then it pops up again and again and again. So in the Bay Area, we've had a lot of issues with that, and we basically got a cease and desist, so it got pretty serious. So something we're taking very seriously at this point. So this next slide is basically trying to decipher, okay, if we know what we're looking for, trying to get very high, trash to low, and we know that it's kind of a moving target, well, how do we kind of scope it, and how do we send our crews more effectively? So this basically just tells you that as kind of you build your radius, your survey area larger and larger, your confidence interval starts to go lower. So autocorrelation analysis shows basically that you have less confidence the wider area you have. So we're trying to get it in a sweet spot. What is the area that we have to inspect, and then how many times do we have to inspect it to be efficient? And then this is basically a really easy illustration of, okay, if you went out 5 times in one site versus 16 times, you start to reduce that certainty. So there's 2 ways to do it, right? You either make your area smaller, right? You can check it more frequently. Or if you really want to be uncertain, you're going to make it about really big, right? A really big area, infrequently, you're going to have a lot of variability, right? And then that's where we have some problems, right? Is high actually high on one day, or is low? So we're trying to get certainty because we need to report it, we need to demonstrate for regulatory reasons that we're actually getting the high areas into the low and mediums. So that's our objective. So this is again a tangible problem, right? So with water quality with Caltrans, we have other pollutants that we track that are like metals and sediment and bacteria. We can't see those. However, with trash, these are kind of like a piece of litter that we're after. This is an example of our next application with AI. And this is again where the data science comes in, because we're trying to now bring in technology, data science, visual inspections to help us again meet our objectives of reducing the amount of trash. So our solution, and again, this is kind of the problem, a lot of trash out there, doing visual inspections, trying to make sure that we get cleaned up and we can document all of that, is considering computer vision. So right now, as many, or some of you know, 2 of the common AI-based technologies for image recognition are classification. So you're going to try to tell apart pictures, a cat from a dog. Object detection, which is what you see here on the right-hand side. So these are actual objects, and then trying to classify what they are. So we're going after object detection, right? We like to, when we go out to do visual inspections, take our photos, tag them, and try to identify, right? Therefore, realizing some efficiencies, right? Because we have to do all of our right-of-way. We're going to go do some devices to pick up some trash, and the areas we can't do, we're going to send out our consultants to go drive, or our maintenance crews, and then they're going to go take photos, and then we're going to use image recognition to help us classify these areas instead of using a clipboard, which is what the regulators want us to do. So, sorry, I know there's some people that we're all taking but we're after hours. So, couple examples. So, Keep America Beautiful has, and this slide deck will release it, but basically they have a big project out on GitHub, which is the litter detection project. They use TensorFlow, autonomous vehicles right there on the right. Google Images, right? Tagging, Facebook, same thing. So all this tagging that's going on is really image recognition in play, and that's a kind of a combination of object detection and classification. So this is our current process. So we're kind of in a hybrid mode. We're really kind of in the upper right. So fortunately, we're able to use a driving protocol where we don't have to go and walk the 50,000 linear miles of highway across California. We're allowed to use a vehicle, which still means that we have to drive 50,000 miles of linear highway. So we use a vehicle map, which is what you see on the upper right. I've been on the ride-alongs. They're very monotonous, very easy to make mistakes. So this step number 3, this is where computer vision comes in. We like to get to this, right? Instead of kind of doing a clipboard where you're basically playing like baseball umpire in a vehicle because you're going 60 miles an hour and you're trying to see documentable size things, right? So subjectivity, error, QA, all that's kind of an issue, right? We're going to have to do these on a regular basis over a very large area. It goes back to variability, right? Like I was saying, you have a really large area, not infrequent inspections, and so again, that causes issues. So we'd like to be able to quantify that, these results. So there again, benefits is reducing the error, subjectivity, and also the time to do these inspections. And then here's the implementation. So kind of give you guys a little bit of a takeaway or homework, but Microsoft Custom Vision, I don't work for Microsoft, disclaimer, but no coding required, easily shared models, reproducible and transparent results. Sorry, TensorFlow fans, this is basically what you can't do in TensorFlow. You can do a Custom Vision because I've done TensorFlow, and therefore I can kind of, because I've done both. And so I kind of went with Custom Vision and this because it was just much easier to use. Most of the people on our team are not programmers, and so it's very difficult to be able to transfer work with consultants that haven't used the technology. And then again, on the back end, it's hosted on Microsoft Azure. So again, it's very friendly for the government crowd because it would play nice with our SQL Server on our stack. So the next steps, and I'll get to a demo real briefly, is basically we are designing an experiment under our consultant contract to do a formal study to evaluate our technologies and also design a formal experiment. Model refinement, so as this study gets underway, is to be able to refine it and make sure that our methodology and the way we set up the experiment is correct. And then we're also working on state water board, so again, there's collaboration, we're not all enemies. We have a trash monitoring work group, we're exploring machine learning, including this technology. And it's up here on GitHub, so OLVTA/code4sac. You can find custom vision, and I've shared it with code4sac. And then last thing is a brief demo. So, really quickly, this is custom vision. So basically, it's customvision.ai, and this is your dashboard. So what I've done is I've preloaded about 50 photos, and so they use a very general model. So you need about 50 to 100 photos to train it. It's a pretty consumer-facing product. And so here are 50 photos pulled from Google Images. And this is kind of an example. So this is how you would literally train the bounding boxes. Whereas in TensorFlow, you have to go and do this whole thing by code. You can basically drag and drop this thing. So if I want to pick up another piece of trash over here, I'm going to snap it. And then I can give it a label. And I can call it trash, or I can add somewhere else, right? Like if I want to tag a car, it might even do it for me. See if it's already done it. So I can say car. I can add another title with tag. And off it goes. And then what I would do is I just basically batch upload these, train these, and it's good to go. And then what you can see is, yeah, these are labeled as trash. So it kind of does some processing for you. So that's what you have here, about 50 photos. And then once these are your tags here on the left-hand side. And then also you can have like multiple workspaces, working on teams. You can get about, I think they said about 250 different labels. So if you want to go and categorize, and one thing with this with trash is you could say, I want different types of trash. I want cigarette butts, cans. It's something you could do with this technology. Performance, so I didn't do such a good job, so I got about 60%, so it's kind of like grades in school, right? I kind of failed. But it kind of gives you different metrics, but again, this is kind of a very broad thing, and so once you're ready to go, you basically do, your images here, and then when you're ready to go, you hit train, and then it'll basically train your model, and then it's on Azure, it's hosted there. You get your results back, and then a little bit more of a tangible thing, so prediction. So this is intended as an API, but for kind of the people that were non-technical on our team, we actually have basically a way to do predictions in the GUI where you can kind of do one-off images, and so this is the output. This is the actual kind of out-of-sample imagery that we use. So different segments of highway, this is out-of-sample, so it gives you back basically a percentage of the correlation in the score. And so again, you kind of get twofold. You get the object detection and you get the score. And then, there you go on the right-hand side. And then as an API, once you've trained it, you basically get an endpoint. And then you would basically you're just going to pay for the product. You would basically pay by API call. And then you get the endpoint and you can use it programmatically. So it's kind of best of both worlds. You could train it with the team. And then you can kind of set the programmers loose to kind of batch the photos and then train against it or test against it. So with that, I think that's 15 minutes.
Have you guys looked into using drones instead of having to strap cameras?
We have certainly done that. There is actually a project that does that. And they actually talked right after me. And it's San Francisco Estuary Institute has an aerial. They've used drones for the environment, so I invite you to, and they actually did a study. This is the study they did, and they gave a talk. So if you go to the California State, the Water Data event on July 2nd, they had the talk after us, and they were kind of the opposite. They used aerial and they used TensorFlow. So you kind of get best of both worlds. We were like consumer-oriented in a car, no programming. They were like custom-built models from the ground up doing these grids where they wanted to train their imagery. And then they flew their drone right outside their office in El Cerrito, like detecting them in the marsh. So their interest is more in microplastics. They're concerned with estuaries and basically microplastics and beads getting into the bay. And so then they wanted to be able to detect, and they had some decent confidence with it. But again, it's a challenge if the higher up you are, the smaller the object is. And then it depended on lighting and how they could get the imagery. But TensorFlow seemed to do, and they were using infrared signatures. So they were able to get reasonable results with TensorFlow. So, yes?
From the Microsoft custom vision, is there a way to export the model into something that can be run on better hardware?
There certainly is. There is, I believe. So if you go here to General Compact, there you go. You can do. You can actually do export capabilities. So you can do. They give you basically any flavor. You could do a Docker image. You could do basically flavors of mobile. What you do here is you set it on General and you retrain it. It'll compact the model and then you can export. So what I have on my GitHub account is basically a Docker image, but you can pull out like TensorFlow Lite and stuff for Android. So and there's a company startup called Literati, and they have actually started using TensorFlow Lite on similar technology, training by object, and then their whole platform is basically to get people to crowdsource trash. So you get like 50,000 people like showing Starbucks cups, and then they can go to Starbucks and kind of do a thing like, hey, you have 50,000 cups out there, would you please? Or McDonald's, you have 100,000, would you please stop, kind of thing. So that's a thing, it's called Literati, and they've also been involved with trash monitoring work groups. So again, it's kind of a joint thing where we have industry involved with kind of the public sector and civic, in a way civic tech, because we're all trying to come up with a better solution to address trash that ends up in the day. So again,
Okay.
yes.
So you said that you pay it per API call. Are there any other pay gates involved? I mean, if you just
no, I can literally, for just fun, I can show you like I think it'll let me in, but you can just go to like Azure portal and I'll show you kind of where you have your instance. But no, it's very, very minimal. You basically leave it, sorry. No, it's like you basically have an instance up and then it just kind of runs idle. I mean, you kind of go in here, it's the portals in the background, and then like I just leave it running, and it's literally charging me like, nothing. Like 5 cents. It's like very, very minimal, but it's like on a free plan. You kind of do a pay as you go, and then this is the back end, and then you just have your instance running, and then they really mean like they have a free trial for you, and then you can just keep it running, and then you just pay for the costs and basically train the model. So again, this made it the most attractive choice based on ease of use, pricing, and just working as a team on the model. So yes, another.
I don't know if you've heard of this, but the company I work for has software they use. It's called Cognition, and they use it for image classification of terrain. So I think they use like satellite imagery, and they can separate. They basically use these rule sets to automate it and separate between trees, grass, streets, houses, signs. I wonder, would something like that work for you, or is that like not really fitting in? Are you saying you guys prefer to take the pictures, or is that just what you've had available?
Well, I can talk to you offline, because I know we have vendors in different divisions, and we actually use it for other parts, not just for trash. We have asset inventory we want to take, condition that we want to do, and again, we don't want to have to keep storing it manually. We want to be able to automate this, so there's a lot of other needs that we see for this kind of technology. One more?
Yeah, I mean, and obviously you wouldn't need to, but if you wanted to dig in and adjust the way that it learns, do you have much access to the hyperparameters?
You can, from what I've seen, they have a vision API just like Google Cloud. I just don't know how much you can actually, because they generalize a lot of it. Yeah, you kind of do a trade-off because it's generalized, so it's very easy to use for the team, but it's not like TensorFlow where you have the workflow. So you're kind of, but I figured, having done TensorFlow, I realized that, okay, I understand it, but no one else does on my team, so that is not going to work, right? So this is more of a practical solution, and one basically now is going to see an end where we're going to throw money at it, we're going to deploy it, we're going to use it, and really use it as an internal QA tool, and then ultimately be able to have, and I'm not even in, this is my former role in environmental engineering, I've since gone on, moved on, and they can then carry this and do this on their own. So I think it speaks to the strength of the product. So a lot of times I think kind of the takeaway here too is that it's great to have cool technologies, but sometimes if you're working in enterprise or like on a team, you have to think about fit. And I think maybe that's the thing that's kind of unsaid a lot of times is there's a bright shiny thing, but if you're in Python and the rest of your team does Excel, better start thinking about Excel plugins or notebooks or something, right? And I face that a lot at Caltrans where I'm not saying that people are, hey, you know, they need to learn what I know, but I need to be able to communicate. It's kind of onus is on me, right? I have the technology, I need to be able to communicate, kind of like I'm explaining to you. I have to explain, hey, we came up with this model, this is the context, and this is how we did it. So a lot of, I think, the success with deploying these technologies internally is to be able to kind of build, you know, kind of iterate on them, start with a prototype, iterate, and then be able to show some success and get buy-in and all that sort of stuff. But a lot of that hinges on communication, how the team can really work on the technology. So.
Thank you.